When we're writing equations of piecewise functions in class, we're basically going to be writing the equations of two lines. And so we'll recall from, hopefully, previous years of math, we remember what equations of lines look like. Y equals mx plus b. So if I can find the slope of a line, its rise over run, and I can find its y-intercept, I should be able to write the equation of that line. So let's go ahead and take a look at how that will work with a piecewise function. So let's start with this line over here. So an open circle and then continues in this way. Well, I'm noticing in this, it's not really a line, I guess, it's really more of a ray since it's beginning at a point, but I can do it just the same way. So it appears that this line has a slope of 1. I can imagine counting up 1 and over 1 to find 2 points. I could do, I guess, slope formula, but we're going to keep it pretty simple. So my slope is 1. So 1x, and then my y-intercept, I can see, well, that's also 1. So the equation of this line would be 1x plus 1. However, remember, it's not really a solid line, so I have to include the if. This is the special part of piecewise functions. I have to describe where this line exists in relation to this dashed line right here. And I can see that that line exists only if x is less than 1. That's where the line exists. And notice I know it's less than because I had an open circle. If it was a closed circle, I'd be less than or equal to. Okay, so there's one piece of the piecewise function. Let's move on to the other piece and describe that one. This line, or this ray I suppose I should say, has a filled in circle and then continues in this direction forever. So again, I need to know its slope and its y-intercept. Once again, I see I have a pretty easy slope to find. It's up 1 over 1, up 1 over 1. So my slope is 1. My y-intercept, I don't really have a y-intercept because it doesn't cross the y-axis because it's just a piece of a line. However, if I extend the line, I can imagine it going backwards, and I can see that my y-intercept would have been -1. Our y-intercepts will be integers for what we're doing, so don't worry about finding it more accurately than that. Once again, though, it's not a line, so I have to include this if to describe where the line actually exists. Again, it begins at that boundary wall when x is 1, and it exists when x is bigger than that, when it's to the right of it. So this time, my if is going to be if x is greater than 1, and this time, since I had a filled-in circle, I can say actually x is greater than or equal to 1. So there's the two rays, the two lines, I guess, that make up this piecewise function. The only thing I'll do to sort of connect it together, you saw in the other way, or in the other videos, what piecewise functions look like. I'll include the bracket just to say that those are grouped together, and I'll give it a function name like f of x. So f of x is equal to, and then there's my piecewise defined function with the behavior of the line, and then when that behavior occurs with the domain.